Alright, this video is going to be helpful for you as far as graphing inequalities with two variables. This is a little bit different than what we've been doing most of the chapter. Most of the chapter has been a one variable. Whenever we graph on a number line. This is going to take us back to graphing with two variables or on a coordinate grid. So the first thing we want to recognize is now we're going to be working with equations that have both an x and a y. So you'll notice the inequality on the screen is 2x minus 3y greater than or equal to -2. And in order to graph all of the points that satisfy that inequality, we first need to recognize again what is a solution. Any solution is going to be a point that makes that inequality true. So you'll notice we've got three different points on the screen, -4, 3, 2, -1, and 0, 0. If we take those points and we plug them into our inequality, notice on the left here, we have 2 times -4 minus 3 times 3. We just plugged in our x and our y into our inequality over here. And then same thing in the middle, x in for x, y in for y, and 0, 0 in for both x and y over here. We just do a little bit of multiplying. And then we have an inequality again without any variables. We've taken those out. But now we have to decide, is this a true statement or not? Because we were plugging in a point, we wanted to know, is this point a solution or not? Well, 0 greater than or equal to -2, I would definitely agree with. 7 greater than or equal to -2, I would also agree with. So we're going to have multiple solutions. But notice -17 greater than or equal to -2 is definitely a false statement. -2 would have been greater than the -17, thinking about negative numbers. So in that case, the first point would have been a false point or not a solution. And then the next two were both true statements. 7 greater than a negative number, 0 greater than a negative number. Definitely true. Therefore, 2, -1, and 0, 0 would definitely be solutions to my inequality. Now, how does that help us? Well, when we go to graph, our solutions are going to help us make that graph. So the first thing we want to realize is, in order to make a graph, we want to try to graph just like we always have. Get that straight line on our screen. Get the inequality in slope-intercept form, because again, that's going to help us graph very simply. If we have an intercept, that's somewhere to start, and a slope tells us somewhere to go, then we can graph that line. Now you could also choose to graph in all of the other ways that we've learned before, using a table, or maybe using x and y intercepts if they're easy to find. But again, I would definitely recommend slope-intercept form. Once we've done that, then we're going to decide what kind of a line we want to make, whether it be a dashed line or a solid line. Remember, much like doing inequalities on number lines, we have to have sort of a stopping point. And we always had to decide between an open circle, which meant the point on the circle didn't count, it's just where our line stopped, or a solid circle, which meant the point was included. It was a true statement, but it was also sort of that stopping point. Anything beyond that didn't work. That's the same thing with a dashed line and a solid line. If we have less than or greater than, we're going to use a dashed line, because the points on the line don't actually work. They're not or equal to. However, the points all on one side of that line will work and the other side won't. So it's sort of like a fence in your yard, right? It's kind of quarantining off what's your yard and what's not your yard. However, a dashed line means that fence isn't included, or think of it more like a sidewalk, right? You can cross it, however, part is your yard and part's not your yard. Whereas a solid line would be more like a fence. It'd be more like a stopping point and includes sort of part of your yard. That's if there's or equal to. Again, much like a solid dot, we're doing a solid line. Once we've got our line, then comes the big part. Then comes, where do we shade? Any point that is a true statement but not on the line means that it's on sort of the true side of the line. So any point that's true, we're going to shade toward, and any point that's false, we technically would shade away. So it's not a bad thing to plug a point in and have it come up false. That just tells you that everything on that side of the line is technically false. So let's try a few examples, and then we'll come back for one more note. So let's head to this next screen. We're going to graph 4x is less than or equal to 12. So the first thing I want to do is I notice there's only one variable. So I'm going to go ahead and divide both sides by 4 and get that to be x is less than or equal to 3. Well, notice I do have an or equal to, So I'm thinking about making a solid line, and it's less than, which we'll get to in a minute. But x equals, and let's go back to our last screen real quick. X equals, remember, is a vertical line. Remember that horizontal lines are y equals, and vertical lines would be an x equals, just a number. So if you only have one variable, it's a fairly simple line to graph. X equals is a vertical line. So I'm going to go to 3, and I'm going to draw a vertical line here at 3, right, with an arrow there. And then I need to decide, well, hey, if x is less than 3, well, does that go left or right of my line? Notice my line's vertical, so I've only got sort of 2 halves to my graph. It's going to be a left of the line or right of the line. Well, I'm just going to pick a point to test. Now, 0, 0 is not on my solid line, so that's a great point to test. So taking 0, 0, plugging the x coordinate of 0 in, we find out that 0 would be less than or equal to 3, which I definitely agree with, which means 0, 0 is a true statement. So that tells me everything to the left of the line will be a true statement. So I'm going to shade in. And notice when I shade, I don't really make it a solid shading. I'm just kind of going to make some lines. But everything in that shaded region, everything to the left side over there of 3 is going to be a true statement. Which makes sense, because anything to the right of that would have been where x was greater than 3. And that's not what we want. X is less than or equal to 3. So let's do the same thing on this next equation to the right. 2x minus 3y is greater than 15. First thing I'm looking at is I have 2 variables this time. I know it's not horizontal or vertical. It's going to be a slanted line of some sort. So the first thing I'm going to do is solve for y. Let's go ahead and subtract 2x over to the right side. Notice subtraction does not make us flip the sign, so that's fine. Then I'm going to divide both sides by negative 3 to get y by itself. And division by negative 3 on the left, divide by negative 3 on the right. And notice divide by a negative, we do need to flip the sign. Instead of greater than, y is now less than. My negative 3's are gone. Negative 2 divided by negative 3 would be a positive 2/3 slope. And a 15 divided by negative 3 gives me a negative 5 for my y-intercept. So I'm going to go down to negative 5 then, and I'm going to make myself a dot somewhere to start. And I'm going to count 2/3 for my slope. 2/3. Again, just because it's an inequality does not mean that we can't take advantage of y equals mx plus b. Now, notice no or equal to this time, which means when I go to make my line, I want to make it a dashed line. So I'm just going to make some dashes to kind of connect those dots. I do not want a solid line. The points that are actually on that line, right, are not included. The line does infinitely go onward though, so don't forget to make an arrow. But if I actually check a point on that line, such as 3, negative 3, if I plugged 3 in for x, I would get 2/3 times 3 is 2, minus 5 is negative 3. And remember, if I'm plugging in negative 3 for y, what I just ended up with was negative 3 is less than negative 3, which is a false statement. The points on my line are false. They don't work, which means if I had made a solid line, I would have been lying to myself, right? But the points on the line can't be true. They're not included. However, I still need to know the shading portion. And again, notice I didn't go through 0, 0. So that'd be a great point to check. If that's true, I'm going to shade everything above that line. If it's false, I'm going to shade everything below. So I'm going to check a point. I'm going to plug in 0, 0. And I notice I went back to the original statement. 0 minus 0 is greater than 15. So is 0 greater than 15? Well, no, that's false. So if 0, 0 is a false statement, everything above the line is false, which means I want to shade everything below the line. Everything down here will be a true statement. And that's how you figure out what's true and what's false on a 2-variable inequality. Let's try a couple more very quickly here on the next page. So step 1, notice they're both in y equals mx plus b form. And by the way, these are examples from your worksheet for day 2 of inequalities. Take a second, try graphing the lines. Remember to decide whether or not they're solid or dashed first. and then decide when you want to shade or where you want to shade. I'll come back with a fully filled in graph here in just a minute, and you can check your answers, and then we'll talk about that true false on the bottom. So go ahead and pause the video now, take a couple of seconds, and go ahead and try graphing numbers 1 and 4 from day 2 of your inequality journey. Okay, so I've got both lines drawn on the graph for you here. You'll notice in the first line we had a y-intercept at 1, so I started up at 1 here on the y-axis, and then a slope of 2/3. So we went up 2, right 3, up 2, right 3. Would have taken us off the graph, but notice essentially also going up about 2/3 over 1, up and again about 2/3 over 1. So either way you count out that slope, you got some good points to work with there. Notice a head and or equal to, so it's a nice solid line. And don't forget the arrows on the end. Then we just need to shade. So again, we're going to decide where should we shade this thing. If we plugged in 0, 0, we would find out that 0 is greater than or equal to 2/3 times 0. So 0 plus 1. Is 0 greater than 1? Well, no, I would definitely disagree with that. The other way to look at this is that y is greater than my line. Y is greater than 2/3 x plus 1. If y is greater than, well, y travels up and down. Greater than is upwards. So I would immediately go ahead and take that, and we would shade that above. I shade above the line up here. Again, not including 0, 0 because it was a false point, but also shading above because its y is greater than. Same thing goes for the next line over here. We again started at -2 because the y-intercept was -2. So we've got a -2 right here. And then a slope of 1 times x. But notice again, no equal sign. So a dashed line going up here. Or as we would say, notice down here on the bottom, true or false statements, the first line includes the boundary line. I would say that's definitely a true statement. Right? That's definitely true. So I would call that one true right there. Whereas the second one, being it's a dashed line, does the line actually include that boundary line? Well, no, I would say that's false. So I would not include the boundary line on that second one. So to tell you what, let's highlight the true statements. So we're going to highlight that one for being true. And we'll call this one red for being false. So that's a no-go. Now, again, on that second line, we also need to decide where to shade. But if y is less than, that's a good sign. We can definitely go below that line. Or again, if we check 0, 0, would 0 have been less than 0 minus 2? Well, is 0 less than -2? Well, no, that's false. So again, 0, 0, notice not in the shaded region. Now, the other true-false statements on the bottom, notice with inequalities, you have lots of answers. You're going to cover essentially probably 3 quadrants every single time. So again, let's highlight yellow the good statements, and we'll highlight the bad ones red. So notice in the first inequality, we're in quadrant 1 up here. We're definitely in quadrant 2. And we even have a little bit of quadrant 3, even though this infinitely goes on. So actually there's a whole lot of points out here in quadrant 3. But notice we never did touch quadrant 4 because we went up and away from quadrant 4. So I would say quadrants 1, 2, and 3 have solutions, and quadrant 4 definitely did not. Well, same thing on the next one. Notice this time we're shaded below, so we're definitely up here in quadrant 1, down here in quadrant 4, and down here in quadrant 3, just missing quadrant 2. So actually let's highlight quadrant 2 red here, because that one's no good. We'll extend that line on that one, which means the other 3 statements should be true. Right? We're definitely in quadrants 1, 4, and 3 on that one. Hopefully that helps you graphing 2 variable inequalities. If you have any questions, be sure to ask your teacher. And good luck, and as always, have fun.